Hey everyone, it's Bob Crossen. I am the Vice President of Content Strategy for Wastewater Digest and the Water and Energy Groups at Endeavor B2B. I am here joined with Quinn Jones. He is Product Manager for Digi. We're going to be talking about how to conserve resources through monitoring and optimization efforts in collection systems. So, Quinn, thank you so much for chatting with us today and talking to us about this rather important subject that I feel sometimes can get overlooked in our wastewater market.
Yeah, thanks for having me on. Good to be here, Bob. Thanks.
Yeah. So, let's get right into it. How can utilities part of what the pitch that we had that I had heard from your folks was optimizing resources by repurposing existing networks in collection systems. Could you talk a little bit about what that means? Like, how can utilities repurpose things that already exist to optimize or monitor their systems in a more effective way?
Yeah, that's a great question. So the word that sticks out in that sentence is repurpose, right?
Hmm.
And that's kind of key in on that for a minute. The assumption is utilities have existing networks already created. Some of them are wired, some wireless. And when you think about that immediately, I think of SCADA systems or AMI systems that are set up, advanced metering infrastructure with utilities. And repurposing, when I think of that, it means to me is enhancing an existing network or adding new data streams to an infrastructure that's already deployed. And from a utility background or perspective, they have really high standards for reliability and security, which we all know.
Hmm.
And in those wireless networks, you already have radio networks or gateways, used on existing pump control applications and alarms. And the thought here is repurposing. Utilities can repurpose those existing networks to carry additional data streams. And a couple examples, like adding sensors to a network. There's lots of different low power sensor options like level sensing, pressure, flow, vibration. It's kind of the standard ones we think about. Even things like temperatures at lift stations or manholes or treatment facilities. Other examples would be moving from an alarm-based system to a real-time or continuous monitoring system. And that's, you think of threshold alarms, on pumps or
Hmm.
levels. And and changing that from just receiving the alarms to more of receiving real-time data on those conditions, so you can better monitor, events like, leaks or when a pump goes down or something like that. And this
Hmm.
is where utilities can expand the coverage, at, at sites like wastewater sites, leveraging
Hmm.
the same infrastructure that's already deployed, like in lighting or metering, but adding that so it can be repurposed or in a wastewater application.
Hmm.
Another thought on that subject is predictive maintenance. I think that's
Hmm.
another great one where um, you know, being able to monitor the pump, or for example, the vibrations on it, the current draw, and even the hours on the equipment, and knowing when something needs to be serviced before it breaks down. And this, obviously helps reduce costs on downtime, and then also increase your assets, the life of your assets, which is critical with wireless networks. So going back to that repurpose, I think the goal is with repurposing an existing network is not to rip and replace it, with something
Hmm.
that's more modern, but looking at ways to modernize it, even things like adding mesh networking or IP-based wireless on top of an existing infrastructure. And this can be done in phases, which
Hmm.
obviously you got to keep budgets in mind when rolling stuff out like this. But yeah, the another thought comes to mind is we've seen some of this in lighting, and I think and as you mentioned at the beginning, some of this is starting to spill over, no pun intended, to to wastewater. And that's one of the applications I can think of is the city of Miami has a connected streetlight network. So it's not wastewater, but they have around 500,000 streetlights that are connecting through a AMI system that was already set there as an umbrella, and they've repurposed that to include the street lighting network. So yeah, again, it's not not wastewater, but here's some examples of how that is taken place and how that can be leveraged for wastewater applications.
Yeah. Well, that kind of leads into the next question I was going to say, of getting some examples. The streetlight example is quite interesting from Miami. So the idea being there that the AMI system was leveraged to assist with some of the streetlight work, and so presumably you could leverage it for other use cases as well to get to optimize those other systems. What are some examples beyond Miami that you're willing to share?
Yeah, so I'll give some broad ones, and then maybe we can give some, drill down in some more specific ones. But you know, um, just looking at some ways that utilities can, uh, put this into practice, so to speak, with wastewater systems is one of the thoughts was, there's moving from wire to wireless, right? Where
Hmm.
a wastewater facility may have been set up initially with a wire system, and moving to a wireless SCADA system is something that is taking place. I think in a lot of cases that's already taken place in a lot of utilities around the country, around the world, and in a lot of cases this is also using the existing instrumentation that's already there, but adding wireless to it so they can actually expand that and cover a larger area without the additional expenses of running conduit and wiring. And then once that network is deployed, they can connect different field sensors and field equipment, that communicates back to a central location. And there's yeah, a lot of, and it also ties into predictive maintenance and continuous monitoring, which I was
Hmm.
speaking about. But that helps do that. Another example, a lot of we've seen is there's a lot of networks that are using serial radios, just VHF
Hmm.
serial radios that have been out for 25, 30 years, and they're used to support a SCADA system. And moving the radio technology to a more modern wireless solution is something that can also take place. And this is something like moving to a mesh network, more modern mesh network, sub gigahertz, IP connected, um, along with faster throughput. Right, this opens up a wide range of different applications where utilities can expand that, and uh, and then again adding different sensors to that type of application, going back to the predictive maintenance, that type thing. The last, I think the last example I can think of here is expanding. So expanding the single-use networks to more of a smart network. And you mentioned it a little bit. The smart drinking water, and that is expanding that into wastewater. And that's you have existing SCADA systems. A lot of times they're point-to-point, point-to-multipoint, adding mesh capability to those, as well as edge uh, intelligence on a device. So having the ability to take sensor data at the edge and do intelligent things with it, like sending alarms or um, you know turning off equipment so that it doesn't burn down, or different things like that. I think there are different wastewater examples that are still emerging, but the pattern follows what's happening in the broader water and smart city deployments. And that's
Hmm.
extending stable mesh networks and to support new operational data needs.
Yeah. So when I think about this, I also think about just um, the breadth of type of utility that's out there. There's a lot of very big ones. There's a lot of very small
Yeah.
ones. So really, my question I think for you is, when it comes to utility size, where does the most success seem to come from currently right now, or like what is the best setup for a utility to leverage this kind of idea and turn it into success for them?
Yeah, that's another good question. Yeah, so I think the opportunity is there for both large and small utilities. Both can benefit,
Mhm.
and for different reasons. You think small utilities think that in a lot of cases they're more agile, right? Can adopt things quicker. But the challenge may be capital, right, and budgets,
Mhm.
right? Not a
Yeah,
not
resources in general, really.
exactly. Yeah, yeah. Not money and people, right? Yeah,
Yeah.
exactly. And but in a lot of cases, adding a new wireless network on in a phase type approach is something that can be done either at a small utility or a large utility. In a lot of cases, that's how you want to do it. You start with a lift station, for example, and add a wireless, update your link on maybe one. Look at sensor input that can be added to that different application, and then expanding that over phases, right? There's again, this is a lighting example, but the city of London implemented a Wi-Sun network that covers 15,000 streetlights, and this was done over a 3-year period of time. So something that they started with proof of concept. They put on a couple, and then it grew, and and then rolled it out to cover that 15,000 different streetlights. And I think small and large utilities have that same can work with that same goal in mind. Large utilities likely have more funding, more resources, but may struggle with the complexity of replacing, or modifying a large install base, right? With that hundreds of thousands or even millions of devices, that you can't move as quick on something like that, and you don't want any downtime in a network like that. So again, starting small, right, in phases, and then moving to a larger deployment, and then other network factors I think come into place, like the current size of their network, the bandwidth limitations,
Hmm.
their ability to incorporate new data streams. Sometimes the bandwidth is not there to add sensor data. So that's, I think, evaluating the different types of mesh protocols and networks that are available. And then it goes back to budgets and approval as well, right? Some utilities are quick to look at new technologies and have the resources and willingness to take on network modernization. Some are a little bit it works. Why replace it, right?
Hmm.
So yeah, I think one of the key thresholds is just three key thresholds is identifying the operational need and pain points where that additional monitoring is needed, and where they need the improved reliability. Another thought is, we've seen this a lot over the years, is just the technology life cycle. Um, some systems have been out there for long periods of time, are starting to hit either sunsets on certain technologies like cellular technologies, and some are based on proprietary networks, and are often force utilities to consider upgrading or repurposing. And you think about the 2G and 3G sunsets. Sometimes technology forces, works in a good way to help utilities look at new technologies and ways to expand their networks and expand those data um, inputs, into their network. So yeah, I think utilities just have to ask themselves, can our current network support the size, the bandwidth, and security of the data that's needed today and years from now?
Yeah, yeah. Well, thanks so much for chatting with me about this, and giving some examples of how you can leverage existing things to benefit communities and whatnot. It's been very fascinating. And for everyone who's watching or listening, for that matter, go check out our video description below. We'll have some links down there to some other smart water and smart utility information, and we'll have a little bit more information about Digi down there too. And once more to Quinn, thanks so much for taking the time to chat with me about this and to share your expertise.
Well, thank you, Bob. Yeah, appreciate being here.